Jeff's avatar. This is a name borrowed from computer games. And Jeff is off on a little quick tour here. His avatar is, I should say. And we've lost our sound here, but it doesn't matter. The building we're heading for right now is an office building, but we've converted that into a laboratory in virtual reality. Students who are wanting to learn about nuclear physics can take their avatars, go into that building and do nuclear physics experiments without ever touching a radioactive material, because it's all virtual. Unlike airplanes and other kinds of vehicles, this vehicle can go right through to the inside of the dome. And now we're descending inside the dome. And Zazen Manby, this avatar sitting here, that's Jeff, can do a full tour. And in the real, if you really are online, you can go inside and you can walk around, your avatar can walk around and you can direct the avatar any place you want to go and investigate, all the way down to the bottom where the water pool is and the crane that operates the thing. You can see the entire plant in virtual reality. These are steam generators down here. These, of course, the fuel rod and the control rod assembly. And as we back away, you can see the rods at the top. And this crane will remove the fuel rods when they need to be replaced, which is, they replace about a third of them every year or so. Jeff is descending, and he's going to, I should say, Zazen Manby is going to leave the site, pass by the steam generators. And these blue pipes are the ones that take the hot pressurized water to the steam generators. But on the way, we're going to go inside the control room, take a real quick look at the control room, and these are avatars. And they're looking at the display and with the computers in the foreground. Then we'll move on, I hope. We come to a dead stop, one or the other. Well, you've already seen this slide. I think Gwyneth showed this, so I won't dwell on it. But this is emission-free electricity in the United States, 74% roughly nuclear. This table is very, I'm not going to spend much time on this, it'd take too much time, but I'll tell you that there is, this comes from the greening age of nuclear power, and there are brochures out on the table with a model, and you will see this table, which basically tells you the amount of energy out divided by the amount of energy required to operate a thing. And you can see that nuclear is the highest of all of them, and the inverse of that is what the other column is. But I won't dwell on that. This is a table showing how little nuclear power has to worry about in terms of grams of carbon generated for each kilowatt hour of electricity generated by nuclear energy. And hydro is very low also. Wind is quite good, but as you see, as you move up towards coal and oil and natural gas, they get a bit bigger and bigger and bigger. This is a photograph taken within the Yucca Mountain tunnel. There's about 5 miles of this tunnel were dug at a beautiful cost. All the experimental work has been done there for years. Like I said, they spent $10 billion in there. This is a diagram which remarkably is out of a high school science book. I was delighted to see it because you don't really see the nuclear fuel cycle. What do we mean by the fuel cycle? There can be the start with the mining or the exploration of finding the uranium. Actually, you don't necessarily need to mine the thing literally. The new method is basically using in situ. You leach it out of by pumping sodium carbonate into the ground, like in Wyoming. You get, basically you get yellow cake right there. And yellow cake can go and be converted. You enrich it as the next step is to 3%. Natural uranium is only 0.7% fissionable. That's uranium-235 isotope. The isotope isn't quite enough to make a sustained nuclear plant operate. So it's enriched to about 3, 4, I think as much as 5% as a rule, although for other plants like the plants used in the Navy are a little higher. enrichment, and then after the enrichment is finished, the fuel is actually fabricated. And uranium oxide is the content of the fuel rods, then to the reactor. So that's all of the front end. That's actually bringing it from the ground into the power plant. And after about a year or three, depending on how much and how much you've scheduled, the spent fuel, it's not completely spent, it's only gotten to the point where it's not operating efficiently because of the contamination due to byproducts. So you take that out and you replace it with fresh fuel. So what do you do with the, quote, spent, let's say I'll call it used fuel, because it can be enriched, right? It can be returned. So this is the fuel back end, as they call it, after it's out of here. Where are we now? The solid line shows what we do and where we leave it with an interim storage. And right now that's where it is. And we had thought it was probably going to go to Yucca Mountain, which would be this arrow right here. High level waste, buried deep underground, final disposition. And like I said, they've collected $30 billion to do that with, but have chosen not to because this plan has been put on hold. Alternatively, you can take the stuff out of interim storage after it's been cooled down, and you can take it to a spent fuel reprocessing facility, such as done in Japan, such as done in the UK, such as done in France, and probably China will be doing it before long. And then you can take the plutonium separately out and reprocess it as a fuel, and the uranium also, you can enrich it again and put it back in the front end of the fuel cycle. And then what's left over, if you reprocess, is only about 5% of this route. If you do not reprocess, the whole fuel assembly, everything, just pulled out of the reactor, and when it's cool enough, you shove it in the ground, which is a very wasteful process, and it takes up a lot of space that shouldn't be used. At any rate, that pretty much describes where we are right now. We are still wondering what the next step will be, whether the president will decide that WIP is a good plan or not, but at least he has stopped all actions while Steve Chu, the Secretary of Energy, and a Blue Ribbon Committee decide where what our next step should be. Part of that's political, because it's, after all, yeah, surprise, surprise. You know, Nevada has never liked this idea. They thought we were dumping on them. In fact, they call it a waste dump, and the sophistication behind this facility is really unimaginable. But at any rate, it's on hold for whether it's political or scientific reasons. I will not comment further. Anyway, this is a photograph of Yucca Mountain. It's more of a ridge than it is a mountain. And back off in the distance is the Death Valley, California. This is 100 miles from Las Vegas. And of course, the Gaming Commission is very happy to see that this is on hold. Well, thank you very much for your attention, and I would like to just acknowledge Jeff Corbin, who has been a very important factor in much of the work we've done.
I'd like to thank Dr. Amee for a very interesting description of the fuel cycle, which is not understood very much. And I wonder how many people knew that University of Denver is teaching or preparing to teach the nuclear environmental impact statement or study evaluations. That's a bit of a surprise.